Good morning. I feel like it's been a long time since I did this, so hopefully I can get back in the swing of things. We are going to do notes today for conditional statements and just kind of introduce you to them and how they work and how you can manipulate them, and hopefully it will help you understand a little bit better. So, first of all, conditional statements means that there are conditions applied. So, as a parent unconditionally loves their child, or at least they should, meaning their child could pretty much do anything and you're still going to love them, conditional statements are the opposite of that. So, they're going to have a condition applied that makes it true or false at different times. In conditional statements, it's very important to understand that the if and the then are essentially stuck. They're glued to the paper, and those will never move, the if and the then. So make sure you understand that you're never going to switch them or do anything with them. They're kind of stuck where they are. The part that follows if is called the hypothesis, just like in science. And the part at the end is the conclusion, just like in science. And because we're in math, we can represent all of this stuff using variables and tend to use P and Q as the variables for hypothesis and conclusion, but those can change in R and S. We see those all the time too, but generally P and Q are good ones. There's an arrow in the middle. It kind of is if P then Q, but the arrow really means implies. So P implies Q. So as I said before, these statements can be either true or false. If you can find even one reason that it could be false, then it is false. And that reason is called a counterexample, which you'll learn more about in my other video. All right, so here's an example. If you eat, then you die. This part right here is the hypothesis. Please notice that I did not include if. If is not part of the hypothesis. This is the hypothesis. So really this would be like P, and this would be Q, the conclusion. Now, we want to decide if this is true or false. So could you eat and then die? Yes, you could choke while you're eating. So that would be true, but if we can find even one reason that it's false, then the whole thing is false. So my reason, my counterexample, would be that I ate this morning and I'm still alive, thankfully. All right, so that's the basics of how it works. So now we're going to talk about how you would change statements from a regular statement to conditional form. So basically, the important thing is that you keep it in the same order, and you just might have to change the wordings a little bit. So we need an if and then, because like I said, those are stuck. And then we're going to rewrite the statement in that form. So if a state is on the East Coast, then it borders the Atlantic Ocean. So if a state is on the East Coast, then it borders the Atlantic Ocean. Now we can decide if that's true or false. Well, by definition, the East Coast does border the Atlantic Ocean, so this would be a true statement. Okay. So how would we write an obtuse angle measures more than 90 degrees as a conditional statement? We're going to keep our if and our then. And we might have to change, like I said, the format of the wording, but it stays in the same order. So if an angle is obtuse, then it measures more than 90 degrees. Do you see how that works? And your wording might be slightly different from mine, but the obtuse part needs to be here, and the greater than 90 needs to be there. As far as deciding whether this is true or false, it seems at a glance like it would be true. Obtuse angles are greater than 90 degrees. But it's got another boundary. An obtuse angle is between 90 and 180. So if you have angle that's 180 degrees, that's more than 90, but it's not an obtuse angle, so this would be false. And that would be the counter example, that there's a straight angle that's 180 degrees. And I want you to take a second and pause the video and make a conditional statement for this fish live in the water. Make sure you pause it and then check it with mine. All right, if it is a fish, then it lives in the water. And as far as true or false, this is true, and I know that because yesterday we looked up the definition of a fish, and it is that it lives in the water, wholly in the water, its whole body. All right, we're going to keep on trucking. We are going to be talking about the variations in conditional statements. And these get kind of confusing over time, so I'm going to use a couple symbols or whatever to hopefully help trigger your memory later. First of all, we talked about the general form of a conditional statement being if P then Q, or P implies Q. And so that's going to be our kind of basic. Converse switches the hypothesis and the conclusion. So instead of if P then Q, it would be if Q then P. That is the converse. The inverse negates it. Negate is part of negative, so it just makes them negative, or the opposite of what they were. If it was I am happy, then negate would be I am not happy. If it was I am not hungry, negate would be I am hungry. Okay, so we use this symbol to mean not. If not P, then not Q. And the contrapositive does both. It makes it negative, and it switches the hypothesis and conclusion. That next little section on there is talking about truth value. And basically it's talking about logical equivalence. So some of these have the same truth value. If one is true, the other is always true, and the opposite. It's the original statement and the contrapositive. Those always have the same truth value. And the converse and the inverse always have the same truth value. So we're just going to do one example of all of these: converse, inverse, contrapositive, so you can see how it works and have an example in your notebook. If you wear booty shorts, then you will get dress coded. That's the original. This is the hypothesis, P. This is the conclusion, Q. And is that true or false? It's true. If you wear booty shorts to school, you're going to get dress coded. Converse, remember, is to switch the hypothesis and the conclusion. But the if and the then stay in place. So if you get dress coded, then you wore booty shorts. That's the converse. These get switched. And as far as truth value, could you get dress coded for anything other than wearing booty shorts? Of course. So this is false. You could get dress coded for wearing your shirt too low. That would be a counter example. Now, before we even go forward, we know that the inverse is going to be false and the contrapositive is going to be true. We don't even need to write them to determine that, because the original and the contrapositive have the same truth value, and the converse and the inverse have the same truth value. For inverse, again, the if and the then are stuck, and we need to negate the hypothesis and the conclusion. So we need to make them negative. If you don't wear booty shorts, then